In this video, we're going to use some IUPAC names to draw the structure of some alkanes. These are generally going to be easier examples. And if you're new to organic chemistry, then you could try some of these. So I'm going to put the IUPAC name on the screen for you. And then you can go ahead and pause the video and try it yourself. And then once you're done, then you can start the video again and see the correct answer and see if you got it right. So for this first example, you can go ahead and pause the video if you want. The parent chain name is heptane, which means that this hydrocarbon chain has 7 carbons. So 1, 2, 3, 4, 5, 6, 7. On carbon number 2 and 3, there's a methyl. So 1, 2, 3. On 2 and 3, there are methyls. And on carbon 4, which would be dosage, this would be that one, you're going to have an ethyl. So that would be your whole structure. Next we have 2, 3, I did it wrong, 2, 3 dash dimethyl pentane. Okay. Go ahead and try that. Feel free to pause the video. This would be the answer because you have 5 carbons in the main chain. And then you have a methyl on carbon 2, a methyl on carbon 3. Now, what if we have 2-methylbutane? Butane has 4 carbons, which looks like this. And then this methyl can be on this carbon if you count left to right, or it can be on this carbon if you count right to left. Either one would be correct. Now, if we have, gotta write the name first, 2-methyl hexane. How are you going to do that? So the way I draw it is this, and then the methyl goes on carbon 2. If we have 3 methyl pentane, how are we going to draw 3 methyl pentane? Actually, let's change that to 3 methyl heptane. Heptane has 7 carbons, which, if you memorize this, this is a McDonald's sign, and that's 5. So if you add 1, 2 more, it's going to be heptane. It's going to be 7 carbons. And then you count either right to left or left to right. 1, 2, 3. On the 3rd carbon, there's a methyl. So, just like that. What if you have 4-ethyl 2-methyl hexane? Hexane is associated with hydrocarbons that have 6 carbons in them, or 6 carbons in the main chain. There is an ethyl on carbon 4. If you want to count right to left this time, just for the sake of variety, carbon number 4, there's an ethyl. Carbon number 2, there's a methyl. So that's how you draw it. Let's talk about 3-ethyl 3-methyl hexane. Similar to our last structure, except that we're going to have hexane again, but ethyls and methyls are all going to be on carbon 3. So if we count left to right this time, carbon 3 is going to be this one. And then we're going to have a methyl coming out of it and an ethyl. So that's what the structure would look like. You could also theoretically draw it like this. Let's look at some more complicated examples. Let's look at 2,3,5 trimethyl 4-propyl heptane. Heptane again is associated with 7 carbons. And then on carbons 2, 3, and 5 we have methyls. On carbon number 4, we have a propyl. A propyl group looks like this. It has 1, 2, 3 carbons, and it's a substituent. Now, let's get some halogen action going. What if we have 1 fluoropropane? Propane looks like this because 1, 2, 3 carbons. Fluoro means fluorine. So on carbon number 1, there's going to be a fluorine atom looking like this. If we have 2 chloro 3 methyl pentane, how are we going to draw that? So the way we would do it is we have pentane, which is 5 carbons, and then on carbon 2 we have a chloro. On carbon 3 we have a methyl. You can put a CH3 at the end, but you don't really need to. This would be your structure. For our last example, let's go over 2,2,4,4 tetramethyl pentane. How would you draw this alkane? So first I would put the pentane, which is the main chain, 5 carbons. On carbon number 2, which you could also interpret as this carbon, we're going to have 2 methyls, and then on other carbon number 4, we're going to have other 2 methyls. So that's what the structure would look like. So these are more beginners practice. They might be slightly challenging to you if you're very new to this, but I hope that video was helpful in helping you understand how to draw these structures using bond line or skeletal formulas. One thing to keep in mind is that, let's say you have a propane, right? The hydrogens are invisible. So if I were to draw the hydrogens, they would all look like this. But it would take too long to do that, so we just assume that whatever bonds that these carbons do not have, that they are going to be filled with hydrogens.